This e-learning provides important information on the measurement of humidity and introduces different measurement methods. Air can absorb a certain amount of water until it is finally saturated with vapor. In the closed container, there is a volume of air above a quantity of water. A temperature of 20 centigrades is present. At this temperature, the air will absorb 17.3 grams of water per cubic meter in the form of vapor. The water vapor content, the amount of water contained in relation to the volume of air, is usually referred to as absolute humidity. The diagram shows the vapor saturation curve. This represents the maximum possible absolute humidity as a function of temperature. For example, if the air volume is heated to 25 centigrades, the air can absorb more moisture. After the equalization processes, there will be 23.1 gram of vapor per cubic meter in the air. If the air is cooled down to 20 centigrades again, it is supersaturated. Part of the water vapor will condense and an absolute humidity of 17.3 gram per cubic meter will be reached again. In open systems, as in our environment, the air is rarely exactly saturated with vapor. If it is supersaturated, the water vapor condenses. In nature, precipitation forms. If it is undersaturated, on the other hand, it can absorb further moisture. The ratio of the actual moisture present to the maximum possible is the relative humidity. For example, air at 15 centigrades can contain 12.8 gram of moisture per cubic meter. If half the water is actually present, so for example 6.4 gram per cubic meter, the relative humidity is 50%. In most applications, relative humidity is of importance. Examples are building services, drying processes, or ripening processes in the food industry. Even simple measuring instruments are able to measure the relative humidity. Further parameters, including the absolute humidity described, can be determined mathematically with reference to the temperature. These require correspondingly more complex instrumentation. Two other parameters derived from relative humidity and temperature are described in the following. When air is cooled, condensate is formed at a certain temperature. The temperature belonging to the saturation point is called the dew point. Very low humidities are occasionally expressed in terms of this temperature. If air with a temperature of 30 centigrades and an absolute humidity of 2.3 gram per cubic meter is present, the dew point is minus 10 centigrades. The dew point is also a measure of the moisture content of the air and is displayed on the measuring instrument. The specific enthalpy describes the energy content of a gas. The parameter can be used to determine how much energy must be added or removed to bring air at an existing temperature and humidity to a target temperature and humidity. In the example, there is a volume of air at 20 centigrades and 35% relative humidity. In addition to additional humidity, 167.6 kJ per kilogram of energy must be supplied to achieve a temperature of 50 centigrades and a relative humidity of 70%. In most cases, the capacitive humidity measurement method is used. In principle, a capacitive humidity sensor is a capacitor whose dielectric consists of a hygroscopic polymer layer. The dielectric absorbs or releases moisture according to the humidity of the ambient air until a state of equilibrium is reached. The moisture content influences the dielectric constant of the polymer material. The capacitance of the capacitor changes. The following electronics determines the humidity from the measured capacitance. For most applications, the principle is well suited. In the high humidity range, however, the principle can only be used with special devices. Due to low measuring surfaces, the system reacts sensitively to contamination and pollutants in the measured medium. In the high humidity range, or with polluted air, the hygrometric humidity measurement method may be the right choice. The method contains a fiber whose length is influenced by the humidity. A special transmission system transfers the experienced change in length to a pointer or potentiometer. In the case of a potentiometer, the standard output signal is 100 to 138.5 ohms and corresponds to a PD100 signal. The systems can be connected to evaluation units for RTD temperature sensors PD100 and output a relative humidity of 0 to 100% for the resistance range of 100 to 138.5 ohms. The systems determine only the relative humidity and no derived parameters. The measurement technique does not require power supply, and the principle is well suited for low-cost hygrostat construction. It cannot be used in very hot gases and is not suitable for measurement in low humidity. The so-called hygrometric humidity transducers show a relatively sluggish response and can only be used for maximum air velocities. The measurement of humidity in polluted or aggressive air can be done with help of the psychrometric humidity measurement method. Psychros comes from the Greek and means cool, frosty or cold. The principle makes use of the fact that in dry air more water is evaporated per unit of time, and thus there is also greater cooling. The psychrometer has two thermometers and can measure humidity in the temperature range of 5 to 95 centigrades. One of the thermometers is directly exposed to the ambient air. This measures the so-called dry bulb temperature. The second thermometer is covered by a cloth soaked with water. It measures the wet bulb temperature. Heat is extracted at the wet bulb temperature sensor due to evaporation, and a lower equilibrium temperature is established. The difference between the two temperatures is called the psychrometric difference. It is greater the drier the air. The two RTD temperature probes of the psychrometer are connected to an evaluation unit. The evaluation unit calculates the relative humidity from the dry bulb temperature and the psychrometric difference. In humophile devices, this is done with the add of the so-called math function. The measurement technology is extremely robust and provides good measurement accuracy in the low to medium measuring range. It is inaccurate in the high humidity range, where there is hardly any cooling. Installation is relatively complex, also because a fan is often required due to the defined air inflow. The system requires maintenance, such as monitoring the water level and changing the cloth. All information about our seminars, webinars, e-learnings and reference books are available on our homepage.